Good afternoon, ladies and gentlemen. So I will talk about process systems engineering, and it's really about crossing borders between different scientific disciplines. And this is very important now in today's life when we see the challenges that are appearing to take care of our planet, to invest in sustainability. And that's what I'm going to be speaking about in the next few minutes. And it is also important for me because I think that many of you don't know what process systems engineering actually is. Let me take an example from everyday life. Here on the right-hand side, you can see a train schedule. It's actually a computer train schedule from Philippines. And well, that doesn't really matter where it is from, but the basic thing what I want you to pay attention is that you have these tables. It's a schedule. There's first the train number, then there are the route from which city it goes to which place, and then you have the departure and arrival time of those trains. So you have this long list here, northbound, southbound, and so forth. But have you ever thought about what is behind all that activity that actually you can get to this point that you can have a train schedule like this? So let me walk through a couple of those avenues. First of all, you have to know from where to where do you have to have people that needs this service of transportation. And then you have to know from which city, how do you build and design your railway network? Because of course you cannot go to every small village. So you have to make it so that it reaches most people and it's not too expensive. So it's always an optimization of design, optimization problem, how to build that network. After that, you have to decide how do I operate this railway network? And here when you operate it, you have to think about when do the people need to move from point A to point B. And probably this is a commuter schedule. Probably you have to think about maybe mornings and afternoons are more critical. So then you have that too defined, and then you get a schedule. Of course, when you think about the operations, you have to think that they don't go over the same point, that the tracks are always free, and that you are trying to do that with minimum amount of trains. Finally, you need the actual devices, the trains that are doing the work. And when you have these devices trained, there are some elements that have to be controlled. A train can go with different speeds. It has different safety and safety control systems. It also, for instance, when you have a curve, you have to maybe slow down a bit and so forth to be able to decide how long will it take for the train to arrive. So those are the elements that you have to take care of. You have to design the railway network, you have to think how do you operate it, and you have to also think about how do you control those individual items that are part of the network. This is actually exactly what process systems engineering also is focusing on, the three aspects of design, operations, and control. This actually was the original scope of process systems engineering from the very beginning in the 1960s until roughly 2000s. Now, of course, we don't talk about trains, but we talk about processes. But the same principle applies to the processes as well. So if we take a small example from the processes, here below you see a flow control loop where you have a flow controller. Then you have a valve that the flow controller can operate, and then you have a flow meter. And the idea here is that the flow controller gets a set point, for instance, a certain number of how many liters per minute, for instance, have to flow through it, and it tries to operate that valve as well as possible to keep the flow stable. So that is one regulatory control loop. In typical production, of course, you have much more of this kind of devices and loops. So this is typically then another problem that you have to go one step up to advanced process control level, or you have to talk about real-time optimization, where we focus more on what should come out on the right-hand side of those arrows. And based on that, the advanced control, process control will set all the set points for the individual control loops. Then there's the operation part that is then basically deciding what should come out at what point of times. Now you might think this looks actually very simple. It's something you can just do on paper and pen. Well, here it might be true, but this is a picture of a process instrumentation diagram of only a part of a plant. So if you look at this complexity, how many control loops there are, you understand that it's not anymore possible. And what you need is mathematics. You need to use mathematical modeling methods to actually capture what is actually happening here and how this dynamics of the entire system looks like. So we need mathematical models. And that's actually the first keyword to the cross-scientific disciplines. Because the process systems engineering was basically created by chemical engineers who, of course, know about processes and wanted to try to optimize processes to make them even better, more efficient. And already mentioned, we started to create mathematical models. And in these mathematical models, they can be either used for simulation or for optimization that tries to find the best possible solutions to optimization problems. And because of that, the first community that is obvious is operations research community that basically provides algorithms and solution ways, methods to solve the optimization problems and give solutions to them. Then once we have the solutions, of course, since we are industrially focused, we need somehow to create tools that can be applied to the industry. And that's where the computer science discipline has already been very early, very present in process systems engineering. And typically it is mentioned as a combination of chemical engineering, operations research, and computer science, if you talk about the discipline. And the focus is often around the mathematical modeling. So actually, when I look at my own career, in 3 days, 30 years ago, I got my diploma, my master's degree, and that was where I had already first time done this kind of modeling of real processes. And after that, a couple of years ago, later I joined the industry. More exactly, about 7 years after my master's, 6.5 years, I joined the industry. And I worked on different industrial problems, on copper industry, pulp and paper, steel, cement, oil and gas, and later on power systems. And I was very lucky to work with very brilliant colleagues in the research centers, as well as very brilliant university collaborators. And we had some success stories, of which you can see some part of them here on the right-hand side. So a success story, of course, it's something where you can do publications, get good scientific publications. And then some of them even were installed in the plants live. So this was all great, and I'm still very proud also with all the collaborations that we have been able to achieve. But what's missing? One of the good things in the university research is that you can actually be much more actively crossing the disciplines between different skills, different experts. And you can also learn from different industries and use that to finding the best general solutions. And this one basically has then taken me forward to look into solutions. How do we look into the future where we don't have only one plant, but we are looking on much broader scope? So let me go back a bit on the scope definition. First, we have a process here below, down. And when we have an individual process, we might focus on stability. A process often is, many processes form a plant, which is focusing on the quality. Many plants typically are connected to an industrial site. And then every site is focusing more on productivity. And then a site belongs to a company or enterprise that mainly focuses on the productivity. So this is a very traditional approach. But today, the more and more interesting and challenging one is a new element, which is environment, where the focus is on sustainability. If you look what's happening out there, electrification is a big change happening in the processes today, especially the process and plant levels. Digitalization, we all know it's been going on for already more than a decade. It goes everywhere. We also have integration needs. Actually, this integration from the enterprise to the process level was a topic that was brought into process systems engineering in 2005 by Professor Grossman. And then we have here globalization. When we look at enterprise, they basically want to produce where it's most economical to be producing, but at the same time, we are reaching the limits of what our planet can provide. So we have to take care of all of this, which means that the challenge is now to create solutions where you have to balance between the cost and balance between the materials we use and produce and the waste that comes out from the processes. At the same time, energy is also a very big challenge because it's an energy transition ongoing where we know, I will say a few words about that later, where we know that this is changing a lot of how processes operate. So with this, the scope is increasing from the traditional design, operations and control. Now we have sustainability is one of the great scope additions, started already with the CO2 awareness already 20 plus years ago. Energy is now very, very big topic, and data due to digitalization, we have to know how to use it in the best possible way. So let me just take a quick example of energy. We all know that we are more focusing going towards non-carbon based energy sources, so it's wind and solar. We also know that wind and solar are not always present, so sometimes we don't have any wind, we don't have any sunshine. So that's something that the processes have to also be able to deal with. And this is where the process and the power systems, the process systems and the power systems, both are very complex systems by themselves. They have to get more understanding and they have to be able to collaborate to make this happen in a smooth way. So that's one challenge. And if you look at, we are really stretching the limits of what can be done. On the one hand, the modeling capability, we see problems are becoming so large that you cannot anymore manually do so much. So what you have to do is you have to make sure that you use the data in the best possible way to make sure that you can actually use the data efficiently also in the modeling part. Compatibility, if we have power systems and process systems at the same time, we have of course different objectives, so we have to make sure that we can handle the multi-objective type of problems. And then the problem size and the complexity also increases. And this is a challenge that also relates to solution times. We need more efficient algorithms. And in order to look at the sustainability, we need to think about the planet not only in one way. For instance, there are many relationships. If you look at kind of ecosystem thinking, this food, water, energy nexus is a very typical example because they impact each other. If we can in those kind of engineer and model the systems that take into account the interactions, then we can actually make solutions that don't live on the expense of the others, but maybe even support each other. This is an example of food, energy and water nexus because they all kind of compete for the same resources for the same space. So with this sustainability aspect, what we need more is we need to get more into other disciplines, new disciplines. And the disciplines are now here, I give in green. Environmental engineering is a discipline that we have to embrace because sustainability, of course, is something that they are very professionally looking at. But also electrical engineering discipline, we have to get much more collaborative inside this PSC, process systems engineering scope, to be able to make sure that we don't violate the power systems needs when we try to improve the processes. And then also all other sciences that are relevant for the problems we are looking can be biology, biochemistry, can be physics, can be molecular science. There's a lot of applications that need different skill sets. And my wish is really to be able to work and enhance the level of process systems engineering to bring also these aspects to the world of optimization and how to improve the future processes to improve the sustainability for our planet. Thank you very much.